killing bacteria. However, there is a disadvantage. We want all these antimicrobials can be easily dissolved in the water. Long chain, the more chain of the carbon, the less dissolved in water. So not easy to be dissolved in water. Therefore, we have to sometimes using with a combination with ethanol again. So you will see methylpropanol, heptol, they have been approved to use it in the United States. Ethanol, bacterial only allowed in some countries. Because of the benzoic acids modified with different type of the alcohol, you can understand it, different type of the alcohol. We call them halobenzoic acids. Okay, this is a story, how they solve the problem. And this picture right here tells you the idea behind this. And you can see all these examples right here. Okay? This is a way, a very smart way, becomes esters. They become an ester, then they try to improve, increase the pKa value, let them more effective to be approved, to be using in different wider range of the food products. So they can be using in beer, in soft drink, in berries, in fruits, in baked foods, and margarine, all kinds of seasonings, dressings, all kinds of food products. So that's an example of programs. I'm going to skip all these. You can read it. It's just a bacteria, because it's not a food microbial class. I'm not going to go over all these things. One more thing I want to mention. We mentioned this, benzoic acids. We want to mention another one is sodium diacetate, which is acetic acids. So I move all these up. Okay, acetic acid. You know about it. pK 4.8, coming from vinegar. Usually it's 5%. However, if you go ahead to see all the ready-to-eat meat or the meat products, when you see the label, you always see sodium diacetate. Now, where it comes from? This comes from acetic acids reacted with sodium acetone. This is called sodium acetone or sodium acetate. When they reacted, what's going to happen? They are going to have this large guy comes out, which is COO, CH3OH, goes O, goes COO, CH3. This product is sodium diacetate. Why do you want to make this product? This is a salt. So number one, it's easy dissolved in water. Number two, this pKa value increased to 5.5. Once you have this guy comes out, all the ready-to-eat meats, raw meats, can be used because the meat pH value is about this one. This is usually, if you get a pK 5.5, you can use the products maybe up to like 6.1. If the product is like 8.1, you cannot use it because this guy will not form. Okay? it's all going to become this, proton and ions. Dissociated one is not go into the cell wall. Now, by the way, because of these acids, their inhibitor bacteria is only rely on the ATP used. For bacteria, there is a CTP, there is a GTP, there is maybe UTP, or other different alternative energy currents. Therefore, they have some alternative way to survive. So, very easy to have acid-resistant bacteria. That's why this is only for sanitation, temporary. If you keep using lactic acid on a beef surface, keep using. Couple of years later or 1 month later, this lactic acid will losing the impact because acid-resistant bacteria start to accumulate colonization and growing. Okay, so that's the story behind that. Other things, I don't think you can read through these. It's pretty straightforward. One more thing I want to mention is back here. Essential oils. This is something we call it's a natural. So what's the definition? Very long. Volatile liquids, rose oil, lavender oil, or some of the even a good example will be when we make a bread. Sometimes we have I kind of forgot about there is one kind of essential oils. Some people doesn't like the smells. I'll tell you later. I forgot about it. Oregano is one of them. Cinnamon. What I'm saying is the cinnamon, or we say cinnamaldehyde. That's a smelling. Lots of people doesn't like it. But it's an essential oil and it's killing bacteria. So kind of those are very strong smelling products. And their primary components is terpenes. Terpene, you know, is composed by 5 carbon, the 5 number carbon, okay, by a different N value. And have aldehydes, esters, phenols. So they used to be used to make perfumes, soaps, flavorings. But later on, they used on the food products. That's essential oils. This is examples of them. Okay, you see the peppermint, rosemary, thyme, lemon, cinnamon. That's one of them. Mint, oregano, blackberry, lime, lemon, cumin, all those. All the examples of essential oils. Now there is a lot, and even rosemary. There is a lot of the paper, maybe 1,000 paper to evaluate the antimicrobial effects of essential oils during the food processing. But they all have a bad side impacts. It's limited on some of the food products because they have a strong flavor and taste. And also it's going to be sometimes volatile, which means evaporated into the air. You may have a strong smelling taste. And also compared to these organic acids, the essential oils are very expensive. Okay, so most of them you do have to do economic analysis. So I just want to briefly go over here to talk about the acids. Now I also want to mention for acids, they do have some side effect. So like we mentioned in the other class, the lactic acid will cause the discoloration of the chicken meat, become yellowish. So we have to buffer it. Therefore, we make it as a lactic acid, citric acid blender. And when you see the bottle in the lab, which is called chick side, is a lactic acid, citric acid blender. The approved concentration is 2.5%. But when you see the veggie side, they just change the label. It's the same thing. Okay, one is specific for chicken meats, another one is for vegetables, but basically they're the same thing. Okay, so just let you know that. So the key point here, what I want to mention is the acetic acids and benzoic acids all these things just give you example how these chemicals works. And all the other stuff, or for the micro stuff, and you can read through it. Okay. Okay. So we finish about here. I will ask Rebecca to do the presentation of this first one. I'll cut this one off.